This video is on the nomenclature of alkanes and also an introduction to the concept of structural isomerism. I'll say that again, structural isomerism. Okay, so naming alkanes. What are alkanes? Let's do a quick reminder. Alkanes are hydrocarbons, which means they only contain hydrogen and carbon. They only have single bonds between the carbons, so they are saturated. And they always have the same general formula, which is CnH2n plus 2. So what I have here is I've got two alkanes, each of which has four carbons if you count them. So this has four carbons and this has four carbons. And now, oh, sorry, really quick thing. I don't like drawing all the H's. So to every dash there would be an H, but I'm going to not draw it. But you can assume there's an H attached to every one of those dashes. So if you count up the dashes on the one on the top, you'll find that there are 10 H's. And if you do the same thing with the bottom, you'll also see that there's 10 H's. But if you look at the structures, they're not connected in the same way. And that makes these two what we call structural isomers. Structural, that's misspelled. Structural, yeah, maybe it's right. Isomers. Now, isomers have the same molecular formula, so they each have four carbons and 10 hydrogens, but they have a different structure, and they're going to have different chemical and physical properties, and they're really different substances, even though they have this in common, and therefore they need different names. Now, I'm going to give you the names of these first two ones. The first one, if it's just a straight chain, what we call no branches off it, we just put a little n in front of it, and then we count the carbons, and there's four, and we go over to the prefix chart, and we're like, okay, that's n-bute, okay? And because it's an alkane, it gets the suffix ane. The next one, so if it was five carbons long, it would be pentane, six would be hexane, etc., with an n in front. If it has branches, though, we're going to need to find a more complicated system to say where the branches are, okay? How long the branches are, okay, and how many there are. So you can view this thing as sort of like a tree trunk, right, with a little branch off of it, okay? So this is like the trunk, and the trunk is basically the longest chain of carbons you can find, and then off that tree trunk there are going to be side chains, or what we're going to call branches. And I'm going to name the trunk here first. So the way you do something like this is you find a number of the main chain. So you number the carbons on here, like 1, 2, 3, and you say, okay, name the main chain. So the main chain has 3 carbons, so we call the main chain here propane. And then we name the branch off it. Now, branches, if they're 1 carbon long, are called methyl. So they take the prefix and put a YL. If they're 2 carbons long, they get an ethyl. If they're 3 carbons long, they're going to be called propyl. Since this is a 1 carbon branch located off of the second carbon, this is going to be called 2-methyl propane. And that's the name of that one. Now I want to do a little bit more complicated one, okay, and incorporate some of the things in. Then we're going to go to the next page and keep going at it, all right? Let me do a little quick erasing here, all right? So let's say you have, for example, something that has a main chain that is, let's say, 6 carbons long. 1, 2, 3, 4, 5, 6. So it's got 6 carbons here, and it's got a 1 carbon branch here and a 1 carbon branch here. And now we have to name this thing, all right? So the first thing you do is you find a number of the main chain. You name it, okay? So this is the main chain, 6 carbons long. It's the first longest chain we can find. So the name of the main chain would be just hexane. That's the chain, right? And the branches on the lowest numbered chain. So we want to, this is poorly written. Basically, we're going to number the carbons, and we want the branches off of the main chain to be on the lowest possible number. So here's the thing. If we start numbering from this side, make this 1, that would make this carbon here carbon number 5. But if we start numbering from this end, that would make this number carbon here 2. And we want to have the lowest possible number. So we choose where carbon 1 is. In this case, it's on the right-hand side. And so this is 2, 3, 4, 5, and 6. And the reason why is what you want to be able to do is, given a name, you should be able to draw a structure, right? So for this one, what you see here is I got 2 branches off of the second carbon. Now, make sure it's clear. These are 2 1-carbon branches. 1 carbon branches are called methyls. If there's more than one carbon branch, we use prefixes on top of that. So for this particular example, right, we're going to name the branches. We're going to call each of these branches methyls, right? And then we're going to use prefixes to give us the number of them. And watch how this works. So we're going to call this dimethyl. That means there are 2 methyls. There's 2 1-carbon branches. And then we're going to put a 2, 2, because that tells us where it's located. So for example, if let's say this was different, let's say if this was over here and there's a one carbon branch here instead, right? Now it still has two methyl groups, but they're not on the same carbon. So now this would be called erasing 2, 3 dimethylhexane. Now let's just break this down. This is the tree trunk. There are two one carbon branches, and this is where they're located. So this tells you the location. This tells you how many of the particular type of branch. This is the type of branch. And this is the length of the trunk, or sometimes they'll call that the main chain. Let's try it again. All right, so here we go. Here we have two examples, example A and example B. B is really complicated. We'll get to that one later. That's much harder than you'll ever see on the Regents exam. Okay, so first thing you do is you look at this thing, you try to find the main chain. 1, 2, 3, 4, 5, 6. So this is, again, it's got 6 carbons. We're going to call this guy a hexane. Then I usually circle the branches. I got a branch here, and I got another branch here. Now each of those branches are one carbon branches, right? So I've got 2 methyl branches. Now I've got to number the carbons on the chain with the smallest possible number. So I have a choice of, again, of making this number 1 or making this one number 1. So the question is, do I want them on the 3rd or the 4th carbon? So I'm going to make this the 3rd carbon because it's a lower number. That doesn't mean the one's always on the right-hand side. It just happened to be the way I've written them. Remember, these are 3-dimensional objects, and I could flip it, okay, and, in 3-dimensional space. All right, so what are we going to name this thing? Well, there's 2 of these methyls, so I'm going to call it dimethyl again. But they're located, and they're both located on the 3rd carbon, so I'm going to call it 3, 3 dimethylhexane. And that's that. That's the name of that guy right there. Now this next one is really long and complicated. Here we go. The problem with this one basically is, where's the long chain? Now the long chain doesn't have to be in a straight line like this. The long chain is the longest chain of carbons you can possibly find. And that's what I'm going to do right now. I'm going to start here. I'm going to start boxing like this. And my longest chain goes all the way up like this. That's my longest chain. And then I'm going to circle all my branches. Little branch, little branch, little branch. Now what you want to notice is I have one long chain, which I'm going to name right off the bat and get that out of the way. So the long chain is 1, 2, 3, 4, 5, 6, 7. It's 9 carbons long. The prefix for 9 is non. So this is going to be a nonane. I'm going to write it over here because I'm running out of space. Nonane. Now I'm going to do the branches. Now, one quick thing. We always alphabetize the branches, which means ethyls come before methyls, methyls come before propyls when we're naming it. Probably won't show up on the Regents, but I figured I would mention it. I'm going to do it the correct way. All right, so now I'm going to name the branches. What I have here is, this is the methyl. I'm going to put a little M next to it. This is the methyl. This is the methyl. And this is a 2-carbon branch. This is an ethyl. Right? So there are 3 1-carbon branches and one longer branch that's 2 carbons long. Now I got to number this. I got a choice. I can make this number 1 or I can make this one number 1. Obviously, I want them on the lowest possible number, so I'm going to make this one over here number 1. This will be 2, 3, 4, 5, and I don't care about 6, 7, 8, or 9. Right? All right, here we go. Let's do the methyls first, and then we'll do the ethyl. Right? So there's 3 methyls. So instead of calling it dimethyl, we're going to change it to trimethyl. If there's 4 of them, it's tetra. Okay, so it's trimethyl, and I put the numbers for them. So they're located at 3, and 2 of them are located on the 4th carbon. Make sure you're clear. This is not an ethyl. There are 2 1-carbon branches off of the 4th carbon. So there's 3 of these 1-carbon branches. They're not connected to each other. All right, they're only all connected to this carbon or this carbon here. So this is going to be 3, 4, 4 trimethyl nonane. And now I got to deal with this. And out front, I'm going to do 5-ethyl. Why 5-ethyl? It's on the 5th carbon. That's the name. 5-ethyl, 3, 4, 4 trimethyl nonane. Now, what I find with many students is it's actually easier, okay, to go in the other direction. Okay, and it sort of solidifies that way if you try this. So, for example, I've got 2, 3 dimethylheptane, right? So what I've done is I've drawn my 7 carbons out here. I've drawn the main chain first. I did the same thing over here. I drew the nonane out here. And now I'm just going to put the side chains on here based upon the name. And maybe this will make more sense. I can draw this properly based upon this name. And everything's connected in the right spot. This tells me how long the tree trunk is. There are 2 1-carbon branches, and they are located on the 2nd and 3rd carbon. So I number my chain. 1, 2, 3, 4. I'm going to stop numbering there. because I only need the second and third carbon, right? What this tells me is there are two methyl groups. One of them's on the second carbon and one of them's on the third. So I'm going to draw a C here and a C here. I can put all my dashes with all the H's on them later if I need to for an exam question, right? And put all the dashes in. That's 2, 3 dimethylheptane. Let's say I have to make this one 4-ethyl 2, 2, 3 trimethylnonane. All right, I'm going to number it again. It doesn't matter if I number, I can make this number 1 if I want. It's the same thing in three-dimensional space. I'll do that just to be a little different. It doesn't matter. Okay, I've got 3 of these methyl groups, 3 1-carbon branches, and they're telling me where they're located. So I've got 1 here, 1 here. The next one is going to go here. I can put it up or down. It really doesn't matter as long as I've got a single 1-carbon branch coming off of the 3rd carbon on the chain. And now I have to have an ethyl group coming off of the 4th carbon, which is a 2-carbon branch. And so I'm going to put up so it fits on the paper, basically. And again, I can put all the H's in later if I need to, etc. And that's how you draw it. Okay, here's 2 last examples I'm going to put up here for you. I think it's the last page. Yes, it is. Okay, so here we go. So I'm going to find the main chain first. If you want to try doing these yourself, all right, that'd be a great idea. And so you could pause the video and then try to do it yourself to see if you know what you're doing. So for this first one, I've got a 3-carbon branch. So this is going to be called a propane. That's my main chain. And I have 2 methyls coming off of the 2nd carbon. So this is going to be 2, 2 dimethyl propane. Reality is you don't need these here because if the carbons were on the end, okay, you would end up with a 4-carbon chain. It wouldn't be a propane, it'd be a butane. But so you could, if you've written dimethyl propane, this would actually also be correct because there's no place to put those 2 methyl groups other than off of the 2nd carbon. Otherwise, it turns into something butane, not a propane. I would accept either one as correct. I don't think the Regents makes a big deal difference about that. The next one, you have to be careful. Again, you have this long chain here like this, and it's not in a straight line. So if you think this is a pentane, that was your mistake when you did this one. So I've got 1, 2, 3, 4, 5, 6 carbons. I'm going to make this the 1st carbon and this one the 3rd one. So I basically have a hexane. Right? If you did this wrong, you probably thought that you had a pentane, but this is a hexane. And what I can see is I've got 2 of these little branches off of this thing that are both methyls, right? And so I've got 3, 3 dimethyl hexane. Notice this is exactly the same thing as we had back here, except I drew it in a zigzaggy way. So this and this are the same exact thing. Just a quick reminder, the key concept that's really going to be important is the concept of isomers, which is not here anymore. Isomers would have, so an isomer of, let's say, this thing right here that we just did would be, let's say, if I erase this and move this over to, let's say, here, that would be an isomer because it would have a different name but have the same form because this thing has basically 8 carbons, so it's going to have 18 hydrogens. But now the name is changed to 2, 3 dimethylhexane. And that might not seem important to you, but for a chemist or somebody making biological molecules like pharmaceuticals, an isomer might be a new important molecule. All the different opioids, they tend to be very similar molecules. Some of them are just isomers of each other. So, oxycodone is maybe an isomer of some of the other chemicals that are found in similar drugs, okay? A slight change in the structure in terms of how things are connected to each other can have a really big effect on something's effectiveness as a pharmaceutical or how it affects things within the body.